Algebra 2, Chapter 12, Section 1, Polynomial Functions. So first let's talk about what is a polynomial. And we can't talk about a polynomial without first talking about monomials. A monomial in X is an expression in the form constant k times x, this variable, to the nth power, where k is constant and not 0, and n is a non-negative integer. In other words, a whole number that's 0 or more. So 0 would be a monomial because, no, sorry, not 0. 0 would not be a monomial in this definition. 1 would be a monomial because we could have k as 1 and x could be to the 0, non-negative. 0 is not negative. We would write this just as 1 because x to the 0 is 1. 3x would be a monomial. 2x to the 7th would be a monomial. A polynomial in X is an expression equivalent to a sum of 0 or more monomials. So a polynomial might have no monomials in it, in which case it would just be 0. Okay, that's a special polynomial called the zero polynomial. A polynomial could also just have one of these monomials. It can be any number but it could be the sum of all of them. It could be 2x to the 7th plus 3x plus 1. That's a polynomial, or a polynomial. A polynomial function is a function whose rule is a polynomial. Okay, so if the rule of a function is not a polynomial, it is not a polynomial function. It's only a polynomial function if its rule is a polynomial. So that's what polynomials are. Let's do some practice. So which of the following expressions are monomials in X? So here we can always tell if we have it by identifying our constant and our n. So our n is 2, our constant was minus 1/9. Okay, so yes, this is a monomial. Here we would have n would be 3/2, which is not a whole number. So no, it's not a polynomial. Or sorry, not a monomial. The square root of 2. Well, here we could think of it being square root of 2 times x to the 0, since x to the 0 is 1. So our k would be the square root of 2. It's fine for the constant to have a square root in it. It's just not a square root over the variable. And our n here would be 0. Here we have 2 times 7 to the x. The x is in the exponent. This is exponential. Exponential is not polynomial. No. Or monomial, either one. This is not a monomial because there's two terms, or two monomials. So no. And then here we would have x to the negative 3 power, which is not a monomial because n is negative. No. So we only had two yeses here. So which of the following are polynomials in X? Well, here we have integer, whole number was 1, that's an integer, constant, so yes. 5 is a special case where we have like x to the 0. The answer is yes. Square root of x is not an integer. The answer is no. This is x to the 1/2. Here x is in the exponent, so this is exponential. No. Now we could multiply this out using the distributive law. We would get x squared plus a bunch of other things that are all monomials. So this would be a polynomial, yes. Here we have a negative power of x because x is in the denominator. So the answer is no, not a polynomial. A box is 4 feet longer than it is wide. So let's draw a box. A box is 4 feet longer than it is wide and twice as high as it is wide. Didn't draw it very good. Let's fix that. If it's twice as high, let's do it more like this. Express the volume of the box as a polynomial function in the width. So the width, W, the height was twice the width, and the length was 4 plus the width. So we can now write the volume as the width times the double width times 4 plus the width. And to show it's a polynomial, let's distribute this all out. We'd have 2w squared, 4 times 4 plus w. Distributing, we get 2 times 4 is 8, w squared plus 2w cubed. And we could reorder this to the higher powers first of the polynomial, which is convenient. 2w cubed plus 8w squared. A deposit of $800 is made into a bank account with an annual interest rate of R. Express B, the balance after 4 years, as a polynomial of R. So the balance is going to be $800 times 1 plus R is the growth factor. And after 4 years, it'll be the fourth power. So here our rate, R, is in the base, not in the exponent, even though this is a thing we studied in exponential growth. We're not talking about time now, we're talking about the rate being variable. So here's our polynomial function. To really show it's polynomial, we should probably distribute this out, which is rather annoying because we're going to have to do 1 plus R times itself many times. This is where a thing called the binomial theorem would be really handy to be able to use. We've not talked about that though. So we'll do this by hand, doing the first pair and the second pair of binomials. So binomial just means two monomials next to each other. So necessarily a binomial is a polynomial. It's two monomials. So you might hear me say binomial. I mean two monomials added together. So here we have 1 times 1 is 1, R times 1 is R, 1 times R is R times R is R squared, which will give us 1 plus 2R plus R squared. Same thing for the second half since they're identical. So then when we distribute against these, we would have 1 times 1 is 1, 1 times 2R is 2R, 1 times R squared is R squared. I like to do these kind of in an array so I don't lose track of where I am. 1 plus, not 1 plus, we're doing multiplication here. 2R times 1 is 2R, 2R times 2R is 4R squared, 2R times R squared is 2R squared. And then finally we have the R squared term. So we have R squared times 1 is R squared times 2R is 2R cubed, R squared, which I think I messed up, this should be a cubed. Because here we had, that's why I like to do this arranged this way so I see these mistakes. So here we had 2R times R squared, that should be 2R cubed. And then we have R squared times R squared at the end, which should be R to the fourth power. So that gives us 800 times 1, and then gathering like terms, we have a 2R and a 2R for 4R. This sort of diagonal kind of looking area, we have R squared, and 4R squared, which is 6R squared. And then 2R cubed and 2R cubed would be 4R cubed and R to the fourth. And then if we rearrange this and multiply by the 800, we'd have 800. You rearrange it so the highest exponent goes first, R to the fourth. 4 times 8 is 32. 3200 R cubed. 6 times 8 is 4800. R squared. And 4R times 800 would be 3200R, and plus 800. Assuming I did all that arithmetic right, this would be the polynomial, which shows you the bank balance after 4 years. Which of the following describe polynomial functions? The surface area of a cylinder of radius r and fixed height h, so that means h is constant, is given by this expression, 2 pi r h plus 2 pi r squared. So if we think of h as a constant, we can group it with the pi, which is also a constant. We have just a number, 2 pi h times r, and then we have 2 pi times r squared. So yeah, this is polynomial. Yes. The balance of a deposit P after t years in a bank with an annual interest rate of r is B of t equals P 1 plus r to the t. But here t is our input, and t, our input variable, is in the exponent. So no, that can't be a polynomial function because this is not a polynomial. The effective potential energy of a sun-planet system is a function of the distance r between the planet and the sun, and is given by g of r is minus 3 r to the minus 1 plus r to the minus 2. Well, here we have negative exponents. Remember, the n has to be 0 or positive. And so the answer is no, it's not polynomial.